Good morning. Good morning, children. So, today's topic is areas related to circles and surface areas and volumes. Areas related to circles surface areas and volumes. These are the topics on which we are going to revise today. Let's start with areas related to circles. Everybody know what a circle is? In the circles also we get circle with center O, then AB is the diameter of the circle. So we know D is equal to 2R. OA is the radius and AB is the diameter. So D is equal to 2R or R is equal to D by 2. We know that. And what is the length of the circle? The length of the circle is equal to circumference of the circle which is denoted by C, and that is equal to 2 pi r. What will be? This is the total length of the circle. If you want half the length of the circle, half the length of the circle, half the length of the circle is equal to semicircle R. That is equal to half of 2 pi r, that is only pi r. So the length of half of the circle is pi r. Then what will be the length of quarter of the circle? Circular R. Length of quarter of the circular R is equal to 1/4 of 2 pi r. That is equal to pi r by 2. Now these are the length of the circular arch. Then length of the arc. Let's have the formula for length of an arc of a circle. That is equal to pi r theta by 180 degree. Or L, the length of the arc is denoted by L. So L is equal to theta by 360 into 2 pi r. We know now about the length or the perimeter, that is also known as perimeter of the circle, is what? 2 pi r. Then we know the sector. Let's go to the sector of a circle. So sector of a circle is bounded by 2 radii and an arc of the circle. Two radii and an arc of a circle. So perimeter of a sector. perimeter of the sector will be equal to 2r plus length of the arc L. So if you go for a sector, this is the center of the circle, these are the radii, and this is the PQ, this is the arc of the circle. So it is equal to r plus L, that is equal to 2r plus L. 2r plus L is the perimeter of the sector. This is the angle described at the center of the circle by the arc of the circle. Then area of the sector. Area of the sector. The area of the sector is equal to theta by 360 into pi r square. This is the area of the sector. Now, area of the sector further we can write as A is equal to half into pi r theta by 180 into r. So that is equal to half into pi r theta by 180. We are saying it is equal to the length of the arc of a circle. So that is equal to L into r. So therefore, area of sector is also written as half L r. This is also the area of a sector. Then, after knowing the sector, we know, let us first find out the area of a triangle. The area of a triangle formed by a chord and the radius of a circle. This is the circle with center O. This is the chord PQ, and OP and OQ are the radii. Now, this becomes a triangle OPQ with angle theta. The angle subtended by the arc PQ at the center is theta. Now, we need to find out the area of triangle OPQ. Get that. Let us draw OM perpendicular to PQ. In triangle OPQ, draw OM perpendicular to PQ. Then PM will be equal to MQ, or PQ will be equal to 2PM. The length of the chord PQ will be equal to 2PM. Now, we know that area of triangle OPQ is equal to half into base into height, PQ into OM. Half into PQ into OM. But we must know the length PQ and OM. Now, in triangle OPM, it's a right angle triangle. OM is perpendicular to PQ, so OPM is a right angle triangle, right angle at M. Okay. Then the angle POM is equal to theta by 2. Then sin theta by 2 is equal to sin of angle theta by 2 is equal to opposite by hypotenuse PM upon OP. That implies sin of theta by 2 is equal to PM upon R, because OP is the radius. So that implies PM is equal to R sin theta by 2. Now you got here. Now PQ is equal to 2 PM. Thus, we get PQ is equal to 2 PM, that is equal to 2R sine theta by 2. This is equal to PQ. Now we need to find out OM. Similarly, cos theta by 2 is equal to adjacent by hypotenuse, that is OM by OP. So that implies cos theta by 2 is equal to OM by R, or OM is equal to R cos theta by 2. Now, we got OM and we got PQ, we get the area of the triangle. Therefore, area of triangle OPM, OPQ is equal to half into PQ into OM, that is equal to half into PQ. PQ is 2R sine theta by 2, 2R sine theta by 2, and then OM is R cos theta by 2. So we got the area of the triangle as area of triangle OPQ as half into 2R sine theta by 2 R cos theta by 2, or that is equal to, this is cancelled, R square sine theta by 2 cos theta by 2. This is the area of triangle OPQ. Now, knowing the area of the triangle OPQ, let's go on and find the area of minor segment of a circle. Area of the minor segment of a circle. Area of segment. We know a segment is a region of a circle which is bounded by a chord and an arc of the circle. So if it is a minor arc, it is the minor segment, and if it is a major arc, it will be the major segment. Okay. So let's come and find out the area of the minor segment here, which is bounded by the arc PQ and the chord PQ. So area of the segment of a circle is equal to area of sector minus area of triangle, corresponding triangle. Area of the sector OPQ minus area of triangle OP. So that is equal to, now area of the sector OPQ, we know area of the sector is given by theta by 360 into pi r square minus area of triangle OPQ, just now we found, it is equal to r square sine theta by 2 cos theta by 2. So this is equal to r square into pi theta by 360 minus sine theta by 2 cos theta by 2. This is the area of the segment of a circle. And this is the area of the segment, minor segment of a circle. If we want the area of the major segment, we have to subtract the area of the minor segment from the area of the circle to get the area of the major segment. Then sometimes we come across the concentric circles. We know what are concentric circles. Concentric circles are the circles having the same center and different radii. So let's have the two concentric circles having the same center and different radii. Let the radius of the inner circle be r and the outer circle be capital R. Then we get a region between the inner circle and the outer circle, this region. This region we sometimes term it as an annulus or area of ring, because sometimes it appears as a ring. So area of ring is equal to area of outer circle minus area of inner circle. So that is equal to pi r square minus pi small r square. That is equal to pi common r square minus r square, pi into r plus r into r minus r. This gives you the area of ring, or it is also termed as annulus, or the area that lies between two concentric circles. Now, sometimes we are given questions based on clocks. Let's see. Some information on clocks. On the face of the clock, so you'll find two hands. One is minute hand, the other is hour hand. Now, we know the angle described minute hand. Angle described by minute hand in 1 hour. In 1 hour, 1 hour 60 minutes is equal to the angle described by the minute hand in 1 hour, that is in 60 minutes, is equal to 360 degrees. Therefore, the angle described by minute hand in 1 minute is equal to 360 by 60. That is equal to 6 degrees. So thus we see that the angle described by a minute hand in 1 minute is equal to 6 degrees. Then let's come to the hour hand. Hour hand, if you see, so angle described by hour hand in 12 hours. The angle described by the hour hand in 12 hours is equal to 360 degrees. Therefore, angle described by hour hand in 1 hour, 60 minutes, is equal to 360 degree by 12. That is equal to 30 degree. So that means the hour hand describes 30 degree in 1 hour on the face of the clock. Okay. Let's find out the angle described by the hour hand in 1 minute. Thus, angle 1 minute. So angle described by it in 1 minute is equal to 30 degree by 60. That is equal to 1 by 2 degree. So an hour hand describes an angle of half degree in 1 minute. So these are some important results or information which you must know in tackling the problems of areas related to circles. Let us now start with the surface areas and volumes. Surface areas and volumes. To start with, let's see a cuboid. So we are talking about now solid shapes. So cuboid. Cuboid, the best example is a brick. It will have length, breadth and height. So we know the LSA, lateral surface area of a cuboid, is equal to 2h into L plus B. 2h into L plus B, because it is equal to 2LH plus 2BH. So it is equal to 2h into L plus B. Then TSA, as it is having 6 faces, total surface of a cuboid are 6. So you have 2LH plus 2BH plus 2LB. So it is equal to twice of LB plus BH plus LH. The total surface area of a cuboid is 2 into LB plus BH plus LH. Then volume. Volume of cuboid. So volume of cuboid is equal to base area into height. Base is a rectangle, so it is equal to L into B into H. This gives you the volume of a cuboid. Then you have cube. Cube is a kind of cuboid in which the length, breadth and height are all equal. L, B and H. So L equal to B equal to H. So we can consider this as L, L and L. So in a cube, all the edges are equal. So we get LSE, lateral surface area. There are 4 lateral surfaces. You know it already. Each surface area is a square, so it is L square. Each of the surface of a cube is a square, so its area is side square. That is here the length we have taken as L, so it is L square. And there are 4 lateral faces, so it is 4L square. Then TSA, total surface area. So again we know that the total surfaces are 6. So the total surface area of a cube is 6L square. And then volume. Volume is equal to, as in cuboid, it is L into B into H. Here it is L into L into L. So it is equal to L cube. That is about the cube. Then next, let's come to our cylinder. Cylinder, the best examples have got gas cylinders and some bottles and buckets, and even the glasses are of the shape of a cylinder. It's a cylinder with base and top with congruent figures. They are not circles. Okay. So this is the radius of the circle, and the height of the cylinder is h. Then here we have got curved surface area. The lateral surface area here is called curved surface area. That is equal to area of the base into height. That is 2 pi r h. Then TSA, total surface area. If you remember, it is CSA plus base area plus top area when it is closed on both the sides. So it is 2 pi r h plus pi r square plus pi r square. Base area is pi r square because it's a circle, and the top is also a circle, so it is pi r square. 2 pi r square. So that is equal to 2 pi r into r plus h. This is the total surface area. The volume of a cylinder is base area into height. Base area is pi r square and height is h. So it is pi r square h. This is for a solid cylinder. Now, if it is a cylindrical shell, then it is empty from inside. It is hollow from inside. It is hollow cylinder or cylindrical shell. Then here the volume will be equal to outer volume minus inner volume, because it is empty from inside. So pi r square h minus pi small r square h. There capital R is the outer radius and small r is the inner radius. Okay. So it is pi h into r square minus r square, or it is also equal to pi h into r plus r into r minus r. Coming to the surface area. Surface area means the total surface area. To get the total surface area, we must know the number of surfaces. So if you see, there are two congruent surfaces, these two. Then outer surface and the inner surface. So there are in all 4 surfaces, 1, 2, the outer surface 3, and the inner curved surface 4 surfaces. So outer surface it is a 2 pi r h, outer curved surface, plus inner curved surface is 2 pi small r h, plus these two, you can take it collectively as 2, twice of area of the ring. They appear to be rings, the top and bottom. Okay, so twice of area of the ring, pi into r plus r into r minus r, or pi r square minus r square. So we have got a formula: 2 pi common, RH plus RH plus r plus r into r minus r. This will give you the total surface area: 2 pi RH plus 2 pi RH inner curved surface plus the base area and the top area, which are the ring area of the ring in the form of ring. So that is pi 2 twice of pi r square minus r square. So we get this as the formula for total surface area of a cylindrical shell. Then from this cylinder, let's go to cone. Cone is just the 1/3 part of a cylinder. So it will be, this is the shape. It's a cone with base as the circle and the top as a vertex. The radius of the circle is r and height h, and this is called the slant height, denoted by L. Then here L square is equal to x square plus r square, because this is a right angle triangle. It's a right angle triangle. So in this, L is the hypotenuse, the slant height. So L square equal to x square plus r square, applying the Pythagoras theorem. So from this we get L is equal to under root x square plus r square. Then CSA, curved surface area of a cone. So curved surface area of a cone is pi r L, where L is equal to the slant height, and that is equal to under root x square plus r square. TSA, total surface area. So total surface area is the CSA, the curved surface, plus the base area. So that is equal to pi r L plus pi r square. So pi r common, L plus r. This is the TSA of a cone. Then volume of the cone. Volume of cone is 1/3 of area, 1/3 of area of the base into height, that is pi r square into h. 1/3 the area of the base into height. So volume of the cone is 1/3 pi r square h. After knowing that, let's come to the sphere. The volume of Earth, our Earth. The Earth is in the form of a sphere. So, let the sphere is of radius r. Then, surface area of the sphere. It has got only one surface. Is equal to 4 pi r square, and the volume of the sphere is equal to 4/3 pi r cube. The surface area of the sphere is 4 pi r square, and volume of the sphere is 4/3 pi r cube. Then comes the hemisphere, half of the sphere. Hemisphere, just the half of the sphere. You see, the half cut lemon is a good example of a hemisphere. This is the radius, and of course this is the height, and that is also equal to r. Then here we have got surfaces. CSA, curved surface area of this, is half of the surface area of the sphere, that is 2 pi r square. The CSA of hemisphere is 2 pi r square, and the TSA is equal to the curved surface area plus the top area or the base area. That is also a circle, so it is pi r square. So it is equal to 2 pi r square plus pi r square equal to 3 pi r square. That is the TSA of a hemisphere. Then volume. Volume of the hemisphere, of course, is half of the volume of the sphere. That is 2/3 pi r cube. Then let's see the spherical shell and the hemispherical shell. Hollow sphere. Hollow sphere, that is hollow from inside. This is R, capital R. then we need to find out the volume of this, or the thickness, this thickness. So volume of hollow sphere is equal to 4 by 3, outer volume minus inner volume, 4 by 3 pi r cube minus 4 by 3 pi small r cube. So that is equal to 4 by 3 pi into r cube minus r cube. This gives you the volume of a hollow sphere. Then hollow hemisphere or hemispherical shell. Hemispherical shell, it's again hollow from inside. The best example is coconut, half of the coconut. This is the hemispherical shell or hollow hemisphere. Okay. The volume is equal to outer volume minus inner volume, 2 by 3 pi r cube minus 2 by 3 pi small r cube. That is 2 by 3 pi r cube minus r cube. Then surface area. Again, to get the surface area, we have to calculate the number of surfaces exposed. So here we have got 3 surfaces exposed to us: the outer surface, outer curved surface, the inner curved surface, and the upper area of the ring. This upper area of the ring. So it is outer CSA. Outer CSA is 2 pi r square plus inner CSA 2 pi small r square plus the area of the ring pi r square minus r square. So that is equal to 2 pi r square plus 2 pi small r square plus pi r square minus pi small r square. That is 2 pi r square plus pi r square, 3 pi r square plus 2 pi r square minus pi square is pi r square equal to pi into 3 r square plus r square. This is the surface area of a hollow hemisphere or a hemispherical shell. Knowing this, let us now come to the last part of it, that is frustum of a cone. If you just look at a cone, this is a cone. If we cut a portion at the top parallel to the base, then the solid that is obtained is called the frustum of a cone. So it has got base and top as circles with different radii. Let the radius of the base be r and radius of the top be small r, the height be h, and this is the slant height L. Then frustum of a cone. Then volume of frustum of a cone is equal to 1 by 3 pi h into r square plus r square plus rr. This is the volume of a frustum of a cone. Then CSA, the curved surface of the frustum of a cone, is equal to L into 5L into R plus R. That is the CSA of the frustum of a cone. Then TSA, total surface area of the frustum of a cone, it is equal to the CSA plus the base area plus the top area. So CSA plus base area pi r square plus top area pi small r square. That is equal to pi common L into r plus r plus r square plus r square. So this gives you the total surface area of a frustum of a core, the volume, the CSA and TSA of the frustum of a core. With this, we complete the surface areas and volumes. We complete the revision for it. Okay. Thank you all.